Hello everyone, my name is Valerio Terragni and I am a postdoc at USI, Università della Svizzera Italiana. And today I'm going to present our latest work on software testability. And this is a joint work with Pasquale Salza from the University of Zurich and from my postdoc host, Mauro Pezze. Software testability expresses the degree to which the software system or component under test supports its own testing. And we want that our software has a high degree of software testability so that we can design more test cases in less time. So therefore, measuring software testability amounts to estimate the effort of testing software components. So be able to estimate the testing effort is very useful because first, developers, they can better identify refactoring opportunities, and second, managers, they can better allocate testing resources. Previous studies demonstrated that there is a correlation between software metrics and test effort metrics. And previous study considered object-oriented metrics as software metrics, and they consider metrics that regard the size and complexity of the test cases for test effort. And by demonstrating that this correlation exists, this is very useful because we can predict test effort given software metrics, which is something that we can compute before writing the test cases. However, the previous studies, they suffer from a few limitations. First, they mostly ignore the test quality. Second, they considered limited number of software metrics. And third, they consider a small number of software projects, at most 8. Now, I would like to convince you about the importance of test quality. So let's say we have two classes, a class A and class B, which have the same size of 1,000 lines of code. So let's assume that in the first case, developers decide that 10 test cases were enough for class A, while for class B, we have 30 test cases. So the question is, which class has a higher degree of testability? So I believe that you would choose the class A because we have less test cases. However, what if I tell you that the first test cases for the first class have 5% of line coverage, while the test cases for the second class have 90% of line coverage? I believe that you will change your mind. So this is to show you that ignoring the quality of the test cases can produce incorrect and imprecise correlation results. The only work that acknowledged this issue is the work by Buchling and Van Dossen, which they made sure that the projects that they analyzed, they had the same or similar code coverage. However, they only analyzed 5 Java projects, so it's difficult to draw a conclusion that they can generalize well. In this paper, we analyze a large number of Java projects with different test qualities. And we were able to do so because in this paper, we propose a normalization procedure so that we can normalize the test effort with respect to the test quality. So let's see now how this normalization procedure works. So let's consider our case of before when we have two classes, class A and class B. So let's start with class A. We want to normalize the test effort value, which is X. So first, we need to choose our target test quality value. In this case, we choose 100%, but the important thing is that we choose the same value for all the normalizations. Then we can simply divide the number of the tests, 10, by the actual test quality value, 5%. So we obtain 100 tests. Then we do the same for class B. So we have still 100% as the target test quality value. And we divide 30 tests by 90%. So the normalized value becomes 33 tests. So these are the normalized values, which is 200 test cases for class A and 33 test cases for the class B. Let's see how we conducted the empirical study. So first, we selected all the Java open source projects with at least 50 stars and 1 fork. We clone the projects and we selected those that have a Gradle build file or a Maven build file. We need Gradle or Maven because we need to be able to compile and run the test cases. Then another requirement is that they must have at least one JUnit test case. So we were able to compile successfully around 1,000 of Java projects. Then we took the 1,000 Java projects to identify the pairs of class and associated test class. And we do so by relying on the naming conventions that say that if I have a class called a connector, I should call this class a connector test. So thanks to this naming convention, we extracted around 10,000 pairs of class and test class. Then we computed 28 class metrics and 6 test effort metrics. And then we executed test cases and computed 3 test quality metrics. In this slide, we show the 28 class metrics. And we try to include all the metrics that were considered by previous studies. And also we introduce new ones, like MBI, which is the number of bytecode instructions, which we believe is a good metric to characterize the size of a Java class. This is because a single lines of code, it might result in many bytecode instructions. Then we consider 6 test effort metrics, which were used by previous studies. And these metrics include the size and complexity of the test cases. Then we consider 3 test quality metrics that we computed by executing the test cases. And these metrics are line coverage, brand coverage, and mutation score. The mutation score is a percentage. It tells you the percentage of exceeded faults that are exposed by the test cases. Then, after we collected all the metrics for all pairs of class and test class, we computed the Spearman Correlation coefficient, which is a number from -1 to 1, which expresses the strength and direction of the monotonic association between 2 variables. In our case, between the class metrics and test effort metrics. And here we can see the map of the absolute value. And the results show that indeed there is a correlation between some class metrics and some test effort metrics. Then we applied the normalization. And here we're showing the map after the normalization by mutation score. And the results confirm the correlation that we observe without normalization, and also identify the new correlations. So to summarize the findings, our results show that the normalization always increases the correlation. And if we consider the 168 pairs of class and test effort metrics, we can count the number of weak, medium, and strong correlations. And we can see that after the normalization, the number of medium and strong correlation increase a lot. And we can see also that we achieve the highest correlation with the normalization by mutation score. And this is not a surprising result, because the mutation score is a better metric to validate a test case, because it evaluates both test inputs and test assertions. So our results, they confirm that size and complexity, they correlate with the test effort. And also they confirmed also a coupling has a moderate correlation. However, thanks to our results, we can also conclude that the cohesion correlates with test effort. So to conclude, software testability is an important problem, software engineering. We need to design software that is more testable, so that we can design more test cases in less time. In this paper, we studied the correlation between class metrics and test effort metrics, and we introduced the novel idea to normalize test effort with respect to the test quality. And thanks to this normalization, we were able to analyze many Java projects with different test qualities. And the results it confirms our hypothesis that the normalization increases the correlation. And this will help us to achieve better prediction of test effort, because the higher the correlation, the stronger the prediction power. If you are interested about our work, you can find at this website our replication package. In this package, you will find the scripts to run the analysis, and also you will find the CSV file. In this file, you will see all the data that we use in our experiments. You can find the name of the project, you can find the URL of the project, so that you can download the GitHub project. Then you will see the class name and test class name. Then you will see also the values of the class metrics, the values of the test quality metrics, and the values of the test effort metrics. Thank you for your attention.